Dear students, welcome to our classroom. So, as you can see here, today we'll be focusing on light, reflection and refraction for grade 10. For grade 10 students, now you have almost 3 months in front of you. And when we come to physics topic, you have 2 topics, 4 chapters, 3 months. So, we'll try to revise the topics, that is light topic and electricity topic. So now today we'll be focusing more on the light topic where we'll see the reflection of light. Okay. So as you know, in lower session you have studied that light always travels in a straight line. We'll just see it here. See. So in lower session you had an experiment where you'll be keeping a long pipe through which you will be able to see clearly the candle flame. And if you make a bend at the center of the pipe, we can't see the candle flame, which proves that light always travels in a straight line. So based on this, we have already studied about the plane mirror. You know what is plane mirror? So in plane mirror, we have a rough surface and a smooth surface. I'll just show you the picture. Just look here. So here we are discussing about the properties of image formed by a plane mirror. So as you can see, a child is looking into the mirror. He is waving at himself. So here he sees his image inside the mirror. But can he get that image on the screen? Not possible. So the images like this, which we get only inside the mirror, is called virtual image. Suppose if we can get it on the screen, then it's called real image. So here plane mirror forms a virtual image. Next is the image is always upright. You can see a pen here. If this is the head of the pen and if this is the leg of the pen, now this is upright. Suppose if it is like this, it's inverted. In the case of plane mirror, it always forms an upright virtual image. Okay. So that's why when we stand in front of the mirror, our head will be in the head position and our leg will be in the leg position. It won't be inverted. The next point is the size of the image will be always equal to the size of the object. Suppose here you can see the child looking into the mirror. He can see his image inside the mirror. His height, his length or his breadth, whatever it is, will be same as his own. The image size and the object size will be same. Next is the distance between the boy and the mirror and the distance between his image and the mirror will be always equal. Or in short, we can say like object distance is equal to the image distance. You can see the kids will be coming in front of the mirror. When they come forward to the mirror, they'll feel like another kid is also coming near to it. When the child is moving away from the mirror, the child feels like, okay, that child is also moving and away from me. This is it. So object distance is always equal to the image distance. Then next property is plane mirror always forms laterally inverted images. Laterally inverted means left side appears right and right side appears left. In your selfie cameras now we have the option like mirror effect, mirror image. So if we click on that, we can see the opposite of it. Left appears right and right appears left. It's called lateral inversion. Best example is writing ambulance in front of the ambulance. They'll write ambulance in the opposite way so that the people going in front of the ambulance, when they look into their rear view mirror, they'll be able to read clearly as ambulance itself. That is one property. You can see here the object is given there, a tree, and its image is also given there. As we told earlier, it is virtual image. You can't get it on the screen. It is upright. Its root is down and the leaves are on top. Next is its size is same size. Then next is it is located at exactly same distance from the other one. Object distance is equal to the image distance. And as we told earlier, left appears right and right appears left. That's laterally inverted. Okay, that's all about the properties of image formed by the plane mirror. We have already studied it. We have just polished what we have studied. That's all. Now we are just moving to the plane mirror. In plane mirror, we have two laws of reflection, which is very important for us. Laws of reflection of light in plane mirror. So as you know, in plane mirror, when a light is going and hitting, we call that ray of light as incident ray. And the ray which comes back after reflection is called reflected ray. So we have an incident ray there and we have a reflected ray there. And you know, the incident ray will be going and hitting at a particular point on the mirror. It can be anywhere on the mirror. So at that point, we'll draw a straight line, which is called the normal. Normal will be always making an angle of 90 degree with the plane mirror. So now we have incident ray, the reflected ray, and the normal at the center. The angle made between the incident ray and the normal, that's called angle of incidence. The angle made between the reflected ray and the normal, that's called angle of reflection. First law states that these two angles will be equal. If angle of incidence is 30 degree, angle of reflection also will be 30 degree. If angle of incidence is 60 degree, angle of reflection also will be 60 degree. Suppose if angle of incidence is 0 degree, which means if the ray is coming through the normal, as per the the angle of reflection also should be 0 degree. So it will just go back to the normal itself. Please keep in your mind. So angle of incidence is always equal to angle of reflection. That's first law. Second law states that this incident ray, the reflected ray, and the normal at the point of incidence. The incident ray, the reflected ray, the normal, that we can have lot of normals on the mirror, but we are only considering the normal which is there at the point of incidence. Okay. So the incident ray, reflected ray, and the normal at the point of incidence all lie in the same plane. Which means, suppose if you are making a ray of light to pass through a particular line, it will just get reflected back like this. And suppose if you are using a laser torch, you'll be able to see the path on your table. Suppose you have a cardboard sheet there, and you're able to see the ray which is going, the ray which is coming. The normal is something which is there in our imagination. And suppose if you bend that cardboard piece down, that time you won't be able to see the ray. It is because that everything is lying on this same plane, like a sheet of paper. It's all lying on the same sheet of paper. If you bend that paper, you can't see it. That's the second law. It is nothing. It just says that the incident ray, the reflected ray, the normal at the point of incidence, everything lie in the same plane. That's all. This is what we have already studied in our session. We are just revising it. That's all. Now, moving on, we have two more types of mirrors. We already studied about plane mirror. Other than plane mirror, we have two more types of mirrors. They are called spherical mirrors. We call them as spherical mirrors because they have the shape of sphere, or they form the part of a sphere. I'll just give an example. So here I have something like it was part of a big sphere, but I just cut out a piece from it. So this was a part of a sphere. I have another piece here. This also was a part of a sphere. So we call this one as the concave mirror, and we call this one as the convex mirror. We'll see the reason for that. First we'll see the concave mirror. In the case of concave mirror, I hope you know the word meaning of cave. So cave means it's the den, line's den, or the place where the line leaves. Just look here. I'll just show you the concave mirror. So we have the concave mirror here. So in the case of concave mirror, this silver coating shows the smooth polished surface from where we'll get the reflection. And this part shows the rough surface. In mirror, rough and smooth surface means the smooth surface will reflect back light and rough surface will not reflect any light. Now just focus on the reflecting surface. Suppose if your reflecting surface is curved inwards, we call it as concave mirror. It's like the cave where the line leads. The line can go inside and leave. So it is curved inwards, which means this part will reflect the light back. Here there is no reflection. So this is called rough surface and this is called smooth surface. So if the smooth surface is curved inwards, this is called concave mirror. Now I have one more mirror here. This one. This one's reflecting surface is curved outwards. So this is called convex mirror. You can see that the rough surface is curved inwards and the smooth surface is curved outwards. Now we'll just compare both. In the case of concave mirror, the reflecting surface is curved inwards. We call it as concave mirror. In convex mirror, the reflecting surface is curved outwards. We call it as convex mirror. I'll just give you one more example. You just look at this ball. I have a ball here. I'm just cutting a piece out of it. Now, you can see a reflecting surface inside. The outside portion is not reflecting, it is rough. So we call it as concave mirror. You can see the reflecting surface is curved inwards. So it's concave mirror. Now, think of this particular ball. In this ball, the reflecting surface is already curved outwards. If I open it, you can see inside we have a rough surface which is curved inwards. So we call it as convex mirror. Fine. So this is convex mirror and this is concave mirror. Concave mirror, reflecting surface is curved inwards. Convex mirror, reflecting surface is curved outwards. So as I told you just now, concave mirror. This is concave mirror. The concave mirror forms the part of a sphere like this. And this is how we represent it. This is how we represent the concave mirror. With one side, we have a rough surface, and on the opposite side, we have a smooth surface. Coming to convex mirror, this is how our convex mirror looks. In convex mirror, this also forms the part of a big sphere, and this is how we represent it. With one surface rough and the other surface smooth. Now, we'll just see the main points about this mirror. Concave and convex mirrors are spherical mirrors which are little new to us. So we have some terms which we should study. So we'll study the terms related to convex and concave mirrors. So first of all, we'll see concave mirror. In the case of concave mirror, here when you see this mirror, this is the smooth polished surface which is curved inside the mirror. In this, once you look at this, you can see a center point here. The center point of the reflecting surface is called the pole of the mirror. When you look at this convex mirror also, this is the smooth polished surface which is curved outwards. Look at this center point. This center point is the pole of this mirror. So think of one thing. This one's pole is inside, this one's pole is outside because of its curvature difference. Now, coming back to concave mirror, this complete area starting from here to here, this complete area is called the aperture of the mirror. It's called the aperture of the mirror. Look at this one. For this one, this complete area is the aperture of the mirror. Now, you already know that this mirror was part of a big sphere. So, we know for the sphere, there will be a center. So, if this was supposed to be a big mirror like this, big sphere like this, for this sphere, this will be the center. This center is called the center of curvature of the mirror. So, this particular point is called the center of curvature. Okay. Now, if this is a sphere, if we draw a line from the pole to the center of curvature, we get a line. This line is called the radius of curvature. It's called the radius of curvature. Okay. We'll just see the same thing in convex mirror. In the case of convex mirror, the reflecting surface is curved outwards, but all these points are present inside. Okay. So, here you have the pole of the mirror and you have the focus here. So, in the case of convex mirror, we have all these points inside the mirror. It's not outside. In the case of concave mirror, we have all these points in front of the reflecting surface. But in the case of convex mirror, we have all these points not in front of the reflecting surface, but in front of the rough surface, or we can say behind the mirror. Let's see. For this one, this is the sphere. This was supposed to be the sphere here. So, but the reflecting surface is this side. So, we don't have any points here. If this is the sphere, this will be the center of the sphere. So, this particular point is called the center of curvature. Now, from the pole, if I draw a line to the center, that line is called the radius of curvature. Okay. Now, one more thing. Suppose we have a long line connecting that pole and this radius of curvature, a never-ending line. That long line is called the principal axis. Okay, this is very important for us. That line is called the principal axis. Same applies here also. From the pole, a never-ending line, a long line which passes through the center of curvature. That line is called the principal axis. A line connecting pole and the center of curvature is called radius of curvature. If we extend this line a little bit further, it's called principal axis. Hope it's clear. So now I should tell you about one more point in this mirror, which is invisible, which we can't find. To tell you about that, I'll just show you the mirrors. This is the convex mirror that we usually have. This is the convex mirror that I have. Now this is the concave mirror that we have. So convex mirror, usually this is the reflecting surface is curved outwards, if you can see, and concave mirror, the reflecting surface is curved inwards. Okay. So now, if I place my convex mirror here, you know, convex mirrors usually won't form real images. It will only form virtual images. You can see inside. You can see something inside. You can't get the image on the screen. But on the other hand, this concave mirror forms image outside. It can form real images. It forms real images on the screen. Just look here. I have my hand here and the reflection of the light is already coming to this mirror. See what happens. See, this is concentrating the light. This is focusing the light on my hand. So this one focuses the light on my hand. Okay, just imagine this point in your mind. So here it focuses the light. The distance between this point and the pole of the mirror is called the focal length. This particular point is called focus or principal focus, and the length between this principal focus and the pole is called focal length. I'll just show you the same thing here also. There is a connection between the radius of curvature and the focus. It is nothing. If the radius of curvature is from here to here, the focal length will be exactly at the center of it. Okay, understood? If the radius of curvature is this much long line, then the focal length will be exactly half of it. Suppose if your radius of curvature is 20 centimeters, then your focal length will be 10 centimeters. So, suppose your radius of curvature is this long, then your focal length will be half of it. That's it. So, we can have the equation. Actually, there's no need of equation. We can just remember that the radius of curvature is double of focal length, or focal length is half of radius of curvature. That's all. So we just see the points that we have seen already. The point at the center of the mirror is called pole. For this mirror also, here we have the pole. Now, second point was the aperture. The complete reflecting surface is called the aperture. Then, coming from here, the center of the sphere is called the center of curvature. Line joining the pole and center of curvature is called radius of curvature. At the center of this particular radius of curvature, we have a point called focus. Actually, when I took that mirror, each mirror has different focal length and different radius of curvature. When this one focused the light on my hand, from my hand to that mirror was its focal length. That was actually its focal length. So from here to here, it's the focal length, and the same distance when we move forward, we have the radius of curvature. Hope it's clear. One more main point that you remember is, in the case of concave mirrors, all these points come in front of the reflecting surface. In the case of convex mirror, all these points come behind the mirror because its curvature is like this. So in today's class, we have seen what is light. Light always travels in a straight line. Then the plane mirror and the properties of image formed by the plane mirror. Next was the laws of reflection of light when the light comes and hits a plane mirror. Then we saw two different types of mirrors other than plane mirror, that is the spherical mirrors. In spherical mirrors, we have two types. One is concave mirror and the next one convex mirror. We saw convex mirror and concave mirror. Coming to these two mirrors, we saw the pole, the center of curvature, the focus, as you can see in the screen. We represent pole using the letter P, center of curvature using the letter C, and for focus using the letter capital F. We use capital letters P, F and C to represent pole, focus, or principal focus and the center of curvature. For focal length, we use the small letter f. Is to keep in your mind. Then for radius of curvature, we use capital letter R. The line connecting the center of curvature and the pole, the never-ending line, long line, that line is called the principal axis. In next class, we'll study how image is formed with concave and convex mirror. We'll try to draw the ray diagrams also in an easy way. Thank you.